We begin tonight with a groundbreaking research project pertaining to PFAS, the so-called forever chemicals that can cause dire health impacts to communities.
Tech companies from across the globe are now teaming up with researchers from the Colorado School of Mines and other colleges to look into a number of possible methods for destroying those chemicals. KRDO 13's Emily Coffey is live at Schriever Space Force Base tonight, where that research will take place. Emily, you spoke to the team leader today.
Yeah, the soil here at Schriever Space Force Base is ideal for the scientists to study these technologies, and that's in large part because of the firefighting foams that have been used here in the past. Now they're looking for the best way to clean up the mess left behind.
From a human health perspective, the primary concern is PFAS contaminated drinking water and people being exposed to PFAS contaminated drinking water.
PFAS are a class of chemicals that can be found in everything from Teflon-coated pans to fast food wrappers. Now, scientists at the School of Mines, as well as other top schools, are working on ways to get the PFAS out. And as Christopher Higgins, the leader of this project, explains, water contamination begins in the dirt.
PFAS sitting in soils or sediments can leach out over time. And in fact, all of the groundwater plumes that exist in Colorado are primarily derived from PFAS being applied at the soil surface and then leaching through the soil and into the groundwater.
Locally, the culprit was firefighting foam that was used for years at the Schriever Space Force Base. It's been an ongoing health risk to folks living out in Fountain and the Security Wide Field region. And it's why so many researchers are now looking for ways to undo the damage that's already been done. The new research project at Schriever is designed to evaluate 9 different technologies for destroying PFAS. One of the solutions is to superheat the soil, which breaks down the chemicals, while another uses a water-based technology. Now the question is, how well do they work and which one is the most effective?
Assessing the efficacy is the way to think of it. So we're developing a framework to compare the technologies.
As for now, the team leader tells me that they're still in the early planning stages and they'll be in full force testing in spring or summer of next year. Reporting live at Schriever Space Force Base, Emily Coffey, KRDO 13.
Sounds good.